Here we go with some help on 134 through 145. Rewrite this equation in standard form. Okay, this that's currently on the screen, that is not standard form. That is slope-intercept form because I can see the slope and I can see the y-intercept. To write it in standard form, you're going to want to get it into this form where you have ax plus by equals c. Basically, you want to have the x part first, then the y part, and then a constant at the end. Okay? So, to get this one the way you want to get the x over to the other side of the equation over here. So I'm going to subtract 2x from both sides. And I'll have negative 2x plus y. Notice I kept the x first and then the y equals negative 5. Okay, I mean, I know I could have written that as y minus 2x, but it would be backwards. And I want it in order with the x and then the y and then the number. Okay, in standard form also, you really don't want to have fractions here or here or here. But I didn't have any fractions in this one, so it's pretty easy. But to have it in standard form, those should all be integers in the fronts of the numbers. So there's my answer right there. Okay, moving on to rewrite this in slope-intercept form. Well, now it's in standard form, and they want it in slope-intercept. Slope-intercept is that kind where you solve it for y, and you put the x part first in your answer. So to get the y alone here, I'm going to take away 2x from both sides, and I'll have negative y. Don't just drop that negative. It's important. 7 minus 2x. Now, I kind of wrote that backwards there. I really should have negative 2x plus 7 instead. All right, so I'm going to do that. You can do it in either order, but you want the x to be first when you're all done. Okay, next thing is I'm trying to get the negative off that y, so I'm going to multiply everything by negative 1. And y will be positive then. And if I multiply this by negative 1, I get positive 2x. And I multiply this by negative 1, and I get negative 7. So there it is. Now that's just handy form, slope-intercept, because it has the slope right there of the line, and it has the y-intercept right there. Moving on. What form is this equation in? This is a very important form. You're going to use this a lot as you get into the upper level math classes. This is called point slope form. There's the slope and there is a point. Now you got to be careful because the point is actually the opposite of those numbers. So, excuse me, the point involved here would be 5 for the x, not negative 5, and 2 for the y, not negative 2. Okay, so 5 comma 2 is my point, and my slope is right there as 4. So this is called point slope form. Okay, usually you say the point first. So point slope form of this equation. All right, and the general form of that, by the way, is y minus y sub 1 equals m times x minus x sub 1. All right, where that is a point and that is the slope. Moving on. What is the rate of growth or decay in this exponential equation? All right. Well, this number on the inside here, that will tell me the rate of growth based on how it compares to 1. So the way I like to do it is I write this out as, in parentheses, 1 plus something or 1 minus something. Okay, now how can I write 1.1? I can write it as 1 plus 0.1. Okay, and that tells me that this is, since it's bigger than 1, it is growth. And the amount of growth is that 0.1, the 10% growth. Okay, so this one is 10% growth. If it had been something like this, y equals 2 and then 0.85 and then to the x, then the growth rate would be, well, I rewrite everything except make this a 1 plus or minus something. And to get 0.85, I'd need to do 1 minus 0.15. And that tells me that in this problem, I'd have a, not growth, but decay, or it shrinks by 15%. Okay? So that's an example of how you figure out your growth or decay rate. This one, That is the quadratic formula. That's used to find the roots. In fact, I like to call it the quadrutic formula, just because it reminds you that it gives you the roots. So often kids will be given an equation like this, and they say, what are the roots? And they just go, I don't know. Well, the quadratic equation, or quadratic equation, which is right here, will tell you the roots. If you know that this is A, and this is B, and this is C. Okay. Rational numbers can be written as a fraction. So every rational number can be written as a fraction. So think of things that can be written as a fraction. Can that be written as a fraction? Yep. So therefore, that is a rational number. If there's anything that can't be written as a fraction, then it's not rational, or it's irrational. So things like pi are irrational because they can't be written as a fraction, because it goes on forever and doesn't repeat. A lot of people think if it just goes on forever, you can't write it as a fraction, but that's wrong. Like 0.33333 or 0.3 repeating. 0.3 repeating. There's a fraction for that. It's 1/3. And so things that repeat are rational numbers. And so therefore, anything that repeats as a repeating decimal is a rational number because it can be written as a fraction. All right? All right, moving on. Give an example of an irrational number. I just did. Pi. The pi can't be written as a fraction because it goes on forever and it never repeats. Another irrational would be any square root that doesn't come out nice. Like square root of 25 comes out nice, that's 5. That can be written as a fraction, 5/1. So anything that can be written as a fraction is rational. So I couldn't use square root of 25, but I could use a square root that doesn't come out nice, like square root of 2. That doesn't come out nice. It's not 1. It's like 1 point something, and it does not come out nice. It goes on forever, and it never repeats, just like pi. So any square root that doesn't come out nice and pi would be your best bets for examples of irrationals. The first 4 prime numbers. Oh, how many people out there think 1 is a prime number? It is not a prime number. 2 is the first prime number. After that is 3, and then 5, and then 7. And it looks kind of like it's odd numbers, but except this 2 is here. So that tells you that's the only even number that there will be, of course. But after that, it's not 9. That's the next common mistake. 9 is not prime because 3 goes into it. What you're looking for on a prime number is the exact definition is a prime number is something that has exactly 2 factors. And that's why 1 is not a prime, because 1 only has 1 factor. 1 times 1 makes 1, and so it doesn't have enough factors. You need to have exactly 2 factors. So a number 3, for instance, we said that's prime. So 3 is prime because it has exactly 2 factors, 1 and 3. 7 is prime because it has exactly 2 factors, 1 and 7. If there was any more factors than that, it wouldn't be prime. All right. By the way, if it's not prime, then it's composite. Composite means that it's basically got more than 2 factors. But 1 doesn't work in either group. 1's not prime and 1's not composite either. All right, so there's a little facts about 1 and prime numbers for you. Cross out the non-integer on this list. Well, integers are like whole numbers that can also be negative. Okay, so that's a whole number, that's a whole number, that's a whole number, and that's a negative whole number, I guess you could say. Although technically a whole number can't be negative, but anyway, that's an integer too. So these are all integers. Anything that's got a decimal or a fraction, that's a non-integer, okay? So this is not an integer here. And I guess you got to be careful with saying that because, well, I can write this as a fraction, 5/1. But that's an integer. Why? Because it doesn't have to be written as a fraction. It can be written as a integer, as a whole number. Anything that's not exactly a number is another way to say it, like not exactly 2, but 2 point something, or 2 1/2, or 2 1/3, anything that's kind of between the whole numbers that are on a number line, including the negative ones, those are non-integers. So again, these are all integers, the ones I circled. The one that's not an integer is that one. Okay. If any even integer is represented as 2n, what would any odd integer be? All right. If you use 2n for an even integer. That's a good idea because if you're going to choose a variable for it and you call it 2n, then no matter what you stick in for n, you're guaranteed to end up with an even number. Because no matter what number you put there, you're going to times it by 2. And by timesing it by 2, you're going to be for sure getting an even. Okay? That's why it's an even number. Now to get an odd number, if this is guaranteed to be an even, to guarantee you're going to get an odd one would have to be one bigger or one smaller than that, right? So if you're out of let's say 298, that was the even number. If I want to get just a little bit bigger, I go plus 1, and that'll be an odd number. Or minus 1, and that would also be an odd number. So 2n plus 1 or 2n minus 1 would be good answers for that one. All right. Next up, if two consecutive integers are n and n plus 1, that means they're numbers that are right after each other in numerical order. Okay, so like if it was 9, it'd be 9 plus 1 makes 10. Okay, those are consecutive numbers. What's the next consecutive integer? Well, after n and n plus 1 would be n plus 2. Okay, so if I have n here, and the next one after that is n plus 1, the next one after that would be n plus 2. All right, does that make sense? I hope so. All right, the old price for gas, $2.80. The new price for gas, $3. What's the percent of change? Percent of change is an important concept, and it's the change over the original. I like to use the delta for change and the O over original. And the change is basically what it was compared to what it is, and you just subtract the two. Okay? So if I go 280 and $3, what's the difference between those two? It's 20 cents. Over the original price, which was 280. It's really easy to get confused on which to divide by. You divide by the older or the original price. All right? So 280, 20 cents divided by 280 comes out to like 7.1%. You'd have to do a long division to get that. But if you had left it this way, I would have understood what you meant. Let's do another one. Let's say it was $5.20 for a small pizza, and it's gone up to $6.20 now for the small pizza. Well, I do the change over the original, and the change here would be $1 divided by the original would be $5.20. And if I take $1 divided by $5.20, I'll get my percent, and that'll tell me what percent of increase it was. Now, many things increase, some things decrease. But it's the same idea, it's just that it's a negative number on top. So if gas price goes down from $3 down to $2, then you'd go, what's the change? The change is minus 1 over what's the original. The original price was $3. Then you'd take negative 1/3, which would be negative 0.3 repeating. So that'd be about 33.3% decrease because it's negative. All right.